Yeah, she said they have like 6 this year. Just her team. It's like that's insane.
All right, before everybody shows up, give me names I don't know.
Michael.
Michael. You don't look like any canonical Michaels. This is challenging.
Sorry. Jeffrey.
Jeffrey. Okay.
Alex.
Alex. Kim. Okay. Say again.
Jimmy.
Jimmy. There used to be way more of us. Is today something interesting?
Apple's outside.
Apple's outside.
Man, fuck those guys.
Just stop passing outside.
Well, we'll give people time.
Well, I have like
It's easier to get it here.
We'll be getting in groups today, or
Maybe.
maybe
The GSIs are working on it this afternoon.
yeah, they can take their time.
Today or tomorrow, I think. At worst, it'll be Thursday when like everybody shows up here to do the group brainstorm.
Two big giant.
I just saw a lot of people. Yeah. Going out around.
oh yeah.
All right, I've got that match. Give me a couple more names. What's your name?
Jessica.
Are you Melissa or are you Melissa adjacent? What's your name?
Tiffany.
You're in like the area Melissa was in last time, which makes things more complicated.
If we're all predictably in the same seat.
Yeah, that would make life a lot easier.
Most of us all the other.
Indeed. The secret to learning people's names in this class is very simple, which is that the more you look like your student ID photo, the more likely I am to know your name. I have that. Like anytime I'm going flipping through the grade book, your picture's there.
Oh, really? Oh.
Yeah.
Dang.
But if you like don't look anything like your student ID picture, then I've got nothing.
Lots of them are from a while ago.
Well, I know that's the problem. Like if you're a senior now and you were 17 when you had your picture taken, like things change.
I know someone who adopts a different persona for each California state ID that he takes.
Okay.
One time it was like a Chippendales, and then another time it was dressed up as a priest. So luckily we probably don't stumble on that too much.
Excellent. You know, that doesn't come up too much on student IDs, fortunately.
I always just remember what people are wearing, but then the next day it doesn't work.
Yeah. Like there was a dude back here with a hat last time. If he doesn't wear his hat this time, I've got nothing.
You know what his name is?
I want to say that was one of our like gyms, but I could be making that up. CS160 students out in the hallway. Apple will not hire you if you don't come to class. How's everybody doing? Excited about connected devices, projects, group assignments, all sorts of exciting things coming today. I sat down to write the second half of this lecture, which is kind of a walkthrough of like what the group assignment looks like, and I suddenly got very frightened for you guys. It's going to be awesome. I'm excited about this. All right, topic today is connected devices. And I want to start with kind of my personal definition of what I mean by a connected device. And this, again, is like not a canonical thing, but it's what I think is important for this class and what I think is going to lead to the best final projects. So when I'm talking about connected devices, I mean a piece of consumer electronics that is in one way or another connected to the internet, that is not a general purpose computing platform, and that interacts with the environment in some way. So we will dig into each of those things, but write that down. That's important. That's going to come up again. All right, so what do I mean by consumer electronics? I mean basically anything that a person, like an individual person, is making the decision to go and buy. So that includes things like connected home technologies, thermostats, lights, energy monitoring, home entertainment. Whoa. It's a tricky place to stand. Home entertainment, things like wireless speakers, media, microphones, things along that line. I mean wearables, so Fitbits, Pebbles, smartwatches, things like that. And I mean medical devices, so bathroom scales, blood pressure monitors, glucose monitors, things like that. Is there anything that jumps to mind to you that I'm missing here, like that fits into the consumer electronics space of connected devices? What's that? Okay, kitchen stuff. Some kitchen stuff, we'll have an example of one of those coming up here pretty soon, actually.
Car related?
Yeah, so there are a lot of so there's two kinds of car related things. There's like GPS devices and like in-home car or in-car tech that I would count. And then there's like things that are more about like hitting the brakes for you when you're about to have an accident. And that I wouldn't count as like consumer electronics. But, yep. Anything else?
It's more of a question, if anything. So in one of the previous slides you had, you were showing the Nest, the Dropcam, the Philips light bulb. Those are all like modern examples of what we consider like, connected home technology and all that. How do we know that this isn't just a fad or something that was just passed?
I'm sure it is a fad to some extent.
Okay.
But I think that ubiquitous computing has been coming for a long time. Like if you look at the UbiComp papers from the 80s and the 90s, the stuff that's happening now was very much like designed in the mid 80s. And I think that a lot of this stuff will stick around, like the smartification of everything is not going anywhere. But some of it is probably a little bit fatty. I think that's a fair critique. All right, so that is what I mean by consumer electronics. Connected to the internet, network connectivity. I mean persistent connections or occasional connections to the internet. Usually when you're talking about persistent connections, you're talking about Wi-Fi or like WiMAX, LTE, that sort of thing. And when you talk about occasional connectivity, you're talking about Bluetooth, BLE, Zigbee, XBee, things like that. And the key point here is that rarely are like connected products standalone devices. They are almost always associated with one or both of a cloud-based service or a mobile app. And the mobile app part of that is what we're going to be kind of focusing on this semester in this class. Not a general purpose computer. So connected devices kind of inherently have limited capabilities in terms of computation, input, output, network power. They are built to do a limited set of things and do them well. This is my first law of connected products. If you can play solitaire on it, it's not a connected product. So that rules out mobile phones and laptops and tablets and smart calculators, starting to get close to ruling out smart watches, as I think smart watches are going in a more general computing sort of direction rather than a purpose computing direction. But yeah, if you can play solitaire on it, it's not a connected device. And in general, the idea here is that form should follow function. So whereas smartphones and tablets have kind of gravitated towards this one form factor for every problem sort of physical industrial design, connected products are purpose-built and purpose-designed for whatever context they're going to be sitting in. Fitbit, it's a little thing that goes in your pocket. If it's something that has to monitor the fans in your house, then it's something that needs to be able to mount to a fan. It's something that isn't just a PC or a laptop. It is built to do one particular thing. And last but not least, they need to interact with the environment in some way. So classically, IoT devices have been kind of sensor-based. So things like being able to detect presence, being able to detect the temperature in the room, finding water so that you know if your basement is flooding, monitoring airflow, monitoring light, monitoring motion around you for security purposes, things like that, are the kind of canonical IoT connected product sort of things. But there's this other kind of part of the world that we're starting to see more of, which is that IoT and connected products also need to be able to change the world around them, right? So they need to have sensors and actuators and motors and servos and things. They need to be able to turn lights on and off, turn the heater on and off, activate wheels or move robots or whatever it is. They have to be able to physically interact with the environment in some way. And this is different and not different from kind of traditional computing platforms. Like your laptop has a webcam that lets it interact with the world to some extent. It has speakers. You can kind of toss your laptop over in the corner and get some good out of it. But these things are made only for that, like made to be influencing the environment, whether you're kind of consciously attending to them or not. Make sense? Questions about connected products before we go forward? Because there's going to be a lot of this today. All right. And importantly, we're talking about kind of a subset of the Internet of Things. So the Internet of Things is this broad term that means something different to everybody that says it. To me, connected products are a better fit for this class. But there is also this like whole rest of the IoT world, which includes things like industrial applications. So, if you run a plant that puts together cars, you might have sensors on every little robot arm actuator mabobber. That is very much an IoT application. It's very much not kind of what we're focusing on in this class. We're not talking about like massive sensing projects. So a canonical example of this was there was a big moats project 8 years ago where they took a like 20-acre part of the redwood forest up in Northern California and put sensors up in all the trees and collected data from them for weeks at a time, and then use that to learn things about like what happens up in trees. Okay. Interesting. Outside the scope of consumer electronics, it's not kind of like one person going and making a purchasing decision. We're also not talking about large-scale connected ecosystems. So examples of that would be Uber. So like the technology that lets you know where the Uber car is and lets the Uber car know that you want it to come to it and then guides it to you is a sort of larger ecosystem than we're going to deal with in this course. Other examples there are connected hospitals, air quality sensors kind of distributed throughout an entire city, city bike rental sort of programs. Things like that are very much within the scope of the Internet of Things, but are not what we're talking about in this particular course. Cool? We need speakers. Sorry. So I want to show you, just for like the next 20 minutes basically, a bunch of videos of like reviews and people using these sorts of devices, because it occurs to me that a lot of you may not have a lot of like hands-on time with a lot of these things. So we're just gonna walk through some of the like big famous players in connected devices and give you an idea of what they're all about. So number one, the first thing that everybody thinks of is the Nest thermostat. This is a home HVAC control system. It behaves in many ways just like a thermostat. They were acquired by Google about 1.5 years ago for $3.2 billion. Good for them. It's exciting.
Here is the Nest thermostat. I currently have it automatically set to heat and cool. So if the temperature gets below 68 degrees, the heat turns on. If it gets above 80 degrees, the AC turns on. But probably this summer I'll set it up so that it'll be 76 instead of 80. Now this is the Gen 1 version. Currently they do have a Gen 2. Here's the appearance with heat. Here's the appearance with AC. You see I did change it to 76. Alright, here is the Kindle Fire Nest app. It's kind of similar to the phone version, but it's a much larger screen and you don't have to turn it sideways. So same thing, click on temperatures, you can change things, schedule. Energy report. And that's pretty much it. If you want to set it to away mode, with the little away button. If your weather outside changes, then you'll see it on the screen. It'll show rain or snow or whatever. That's pretty much it. Here is the website version.
Nobody gets to make fun of his video until you've done your own videos for your final project?
Nest. So as you can see, since it's nighttime, it's switched over to night. Upright view, you can change your temperatures. Turn it sideways and you can see the rest of your settings. And with at a glance, you can see your detailed settings.
Alrighty. Some of my favorite individual programming assignment 1 videos had musical scores to them, by the way. Alright, so what did we learn from that? Step 1, who was like blown away by that? Who was like, man, I never in a million years would have thought of that? Okay, nobody. $3.5 billion freaking dollars. All right, this is why we're excited about this space right now. Is that like coming up with good ideas that haven't been taken already in consumer, connected devices is not that hard. I call 5% of your company when you go out and make your $3.5 billion. So what sort of sensing or actuation capabilities did the Nest show off in that particular video? Yeah. Okay, so it knows something about the weather. I think that it is getting that from the internet. Yep.
I think it had a sensor, like when you saw it when he was recording, it had a little blinking thing. I think that was a sensor that makes it so that the display appears.
Yeah.
Or turns on when you're standing.
Yeah, so that's a proximity detector that knows when you're in front of it. Back in back.
It can sense the time of day.
Okay, it knows the time of day, and it can, to some extent, like pull down whether it's nighttime or daytime based on that. Yep.
It tracks usage over time for the energy report.
Okay, so it stores some information about like how it's been used. Do you think it stores that on the device or in the home or in the cloud? Probably in the cloud. Other thoughts? Yep.
Temperature sensors.
Okay, it's got to have some sort of temperature sensor. It's a thermostat. How about actuation? Yeah, so it can control your HVAC system. It can do the heater and it can do the AC. Makes sense. All right, candidate number 2, Philips Hue. This is a connected lighting system. It is marketed primarily as being about doing colorful and interesting lighting in your home. It is in basically every hardware store and Target and things like that if you walk into them. Extremely popular in Europe, a little bit less so in the US. Presumed that they have at least $1 billion in sales. They haven't released any sales numbers, but I would guess it's in the $1 to $1.5 billion sort of range. I give you the Philips Hue.
This video is sponsored by BMI Solutions, your one-stop shop for document scanners in the UK. Check out bmisolutions.co.uk. Hi everyone, this is Dave from Geekanoids. Now, a couple of days ago, I unboxed the Philips Hue, a personal lighting system that you can control with your iOS device. Now, the setup is really simple. You just pop the bulbs into your ceiling lights or your lamps. You connect the Philips Hue hub to the mains and to your wireless router. A push of the button connects it to either your iPhone or your iPad, or perhaps you've got an iPod Touch, and then you are ready to go. Now, I've got this connected to 2 bulbs currently. One is in a ceiling light and one is in a table lamp. Now, I've removed the lampshade off of the table lamp. Normally, you would leave that in place, but I've removed it just for these demonstration purposes. Now, I've got the app running on my iPhone 5 here. Now, you can run it obviously on an iPad as well. And for this demonstration, I'm going to show you it running on an iPad purely because it's got a bigger screen. So let's pop my iPhone off to one side. And you can see the layout of the application straight away. We've got various scenes that we can choose from. And for example, we could choose, say, for example, pencils. And this switches the lights on to reflect this particular scene. And then we can even go into pencils and we can edit that scene, which is really rather cool. So we can drag these points around and change the lighting. And then we've got things like deep sea. So again, this changes to this particular scene. And then we've got Kathy, and again, a different scene again. And we can tap on that pencil and we can perhaps drag number 1 to orange, and we could drag number 2 to green. We can even control the separate brightness of the lamps as well using these sliders. So a lot of control given over the various scenes that are preset. We can also make our own scene. So we can choose here from taking a photo, going into our library or into Philips, or a light recipe. Well, I'm going to go into library and go into my photo stream. And let's select a scene from a photo that I've taken before. Let's choose this one. And again, we can scale this. So we will scale it to roughly about there and say use. And then we can tell it which lamps to actually control. Well, we're just going to control 2. So we'll turn that bottom one off. And then we can drag these onto the photo. So number 1, we have a blue, and number 2, we will turn to green. How cool is that? And this all controls the lights. We can even set schedules, and then we can save the scene and give it a name. So let's call this landscape. And tap on OK. And then we've got that scene that we can simply tap on to invoke and change the lighting to that particular mood. There is a second page of presets as well. We've got things like energize, reading. Now the reading one's very bright, so it gives you a nice reading light. And you can have this to control 1, 2, or 3 lamps. You can even buy additional lamps as well. We've got a swipe up panel here where we can control the different hues of the lamps again. We can also go into settings and see the configurations page. And we can also tap the all off button and then switch all of the lights off.
It's a very important feature in your light switch, ability to turn it off. Somebody talk to me about the Philips Hue. Are you excited? Yeah.
Yes. I think it's cool.
I think it's cool.
Like
I don't know that I would buy one, but I think it's cool. Yeah.
I think it would like it more if it came with like a sound system and like you could set it to like party or like romance or like go to
You're-
sleep or something like that.
You're not the first person to think of that. We'll come up with that on the next slide.
I just don't see myself sitting in a room that has red lights or green lights or blue lights.
So it turns out some people are super into this. Like, I don't know what they're doing in their home, but so I will tell you the one big one is that there's this subset of the like home theater enthusiasts that insists that the lighting around their TV be like perfectly calibrated to like make their TV right for whatever they're doing. And so there are people that are like all hell bent on like, I'm gonna kick my Philips Hue lights into like, I'm watching sports mode. And then like the lighting changes and it's supposed to make your TV better. I only sort of get it, but that is what it is. Yeah.
That's actually really helpful. I have some apps.
See? Yeah, so again, not the like most innovative thing in the world. It's interesting, but like you could have thought of that. $1.5-ish billion in sales. And it gets to something that's really key to consumer electronics, which is that if you had made an app that does something cool, you're maybe selling it for 99 cents. More likely, you're just giving it out for free and putting ads on it. If you're selling Philips Hues, you're selling that box for $200 freaking dollars. And your margin on it is probably 60% or something. And so you would have to sell, what, 200 of your apps to make up for one little sale of a Philips Hue thing. Yeah.
And that's if your app isn't pirated or a person has an app.
Yeah, I mean, exactly. So it's not a bad space is what I'm trying to tell you. All right, LifeX. LifeX was created around the same time as Hue. They went the crowdfunding route, and we will talk more about crowdfunding later in the semester. I think maybe I'll bring in some of the Kickstarter or Indiegogo people to sit on a panel at some point. But crowdfunding is a big part of what's going on in the like connected consumer devices space right now. As VCs are a little wary, incubators are very excited about the space, but VCs are still learning. And so a lot of the money going into this space right now is going in via crowdfunding. So LifeX raised $1.3 million on Kickstarter in about a month. And now they're out there doing their thing. And here's a
New tips. Welcome to part 2 of our LifeX Lightbulb review. We're going to take a look at the features of the bulb and how it works with the app for Android and iOS. First, we're going to install the bulb in a lamp we have here. Alright, I've got the bulb plugged in. Now we're going to take a look at the app on my iPhone. I've already got the bulb set up, so it will work right away. If I save the brightness, you can also try and change the shades from whites to a bit of yellow and even a bit of gray. Now the colors, the app supports the bulb, and the app supports 16 million colors. So you can choose all your variations here, and you can make it either brighter or lighter, and it's going to the different color combinations. Now this is most of what the app does, but there's one feature that's specific to the iPhone app at the moment, which is called scenes. What you can do is you can add new scenes, create a custom name, set up all lights. This is helpful if you have more than one light. You save it and you can select it whenever you want, and it will just turn on the lights with the colors that you had set up. So apart from this, you can manage all your bulbs. If you have multiple LifeX bulbs, you can add new ones from here as well. And there's a quick link to buy more bulbs as well. You can even group the bulbs separately in case you have bulbs in different rooms across your home. You can also edit bulbs and remove them. You can also power them on or off from here, or they can be powered on and off from here. Apart from that, the settings doesn't have much. It's just help, and that is all we have with the app. I'm gonna turn it to some brighter shade, and that's it. So basically, the app is about to be updated, and the features that are coming soon include notifications for social networks, which includes Instagram, Facebook, and the likes. feature which would allow you to set the light bulbs to wake you up or dim to take you to sleep. Welcome home light. So when you enter your home, it should automatically detect that you are home and turn on the lights. You can also set up various moods, kind of like presets, and you would be able to sync lights with your music. So think of it like a personal disco. X also claims that their bulbs can last up to 27 years, which is a very long time. Their bulbs are also very energy efficient, and they even put up a calculator on their website where you can compare the energy used against normal bulbs. Folks behind LifeX Bulb are also working on an API and IFTTT.com integration. Once they are available, we should really see the ecosystem for LifeX Bulbs flourish. That's all we have on the LifeX Light Bulb for now. We will take a look once again when the app updates are released and a developer API is also available. If you have any feedback or questions, put them down in the comments below and like our video on YouTube. If you want to see more videos like this, subscribe to our YouTube channel.
Okay, so there's LifeX. It's a competitor to Hue. It's being kind of promoted by the rest of the world because Philips kind of dominates in this space, and people would like to see a second player involved. What was different about that experience versus the Hue experience? Yeah.
So you had a central hub. LifeX, I'm assuming, at least get it right, should mean that I'm guessing the connectivity options are different because your LifeX, all of them are connected to the server as opposed to Hue, where all of them are connected to your hub, and that's connected to the server.
I think that's true. So I think Hue talks over Zigbee. I think LifeX talks over Wi-Fi. So yeah, the configuration experience is a little bit different. Yeah.
I might be wrong, but I think the color wheel selector, like when you swipe through it, it extended the part that you were on, I guess, so you could like minor.
Yeah, so a very different kind of color selection method. So Hue went with this like, we're going to choose natural tones out of photographs sort of user experience, whereas LifeX did more of a just like color picker. Agreed. And it had some interesting features in terms of how that works. Yep.
I really enjoyed the LifeX brightness slider. It just seemed very satisfying to use.
Yeah, so that gets to a point where like I'm not sure exactly how you do that on the Hue. Like the LifeX strikes me as being better at being a light bulb than the Hue does, whereas the Hue strikes me as being more about this like color immersion fun thing. I don't know which of those lasts longer though. Like maybe people prefer it to be in this model. Yep. Somebody, anybody?
It seems like the LifeX was easier to like control individual colors on each of the lights, whereas with the Hue you had to go into a preset thing and like adjust it based on what it just seemed like it was more to shape one bulb.
Yeah, I think so. I think that just for using it as lighting, the LifeX seems more obvious to me. Yep.
There's actually on the Hue, there's like a side thing where you can just like blow it up into like a big color.
To pick the color wheel.
Yeah,
that makes
so
sense.
You can do that too.
Cool.
Well, like to the LifeX, you could group like lights together. So like say you have like 20 of these in your home, like you could group them together rather than like select them one by one.
I think the Hue lets you do that too, but yeah, it's more obvious kind of how you do this grouping and mapping stuff. The other thing, yeah.
I was going to say the update with the social media links, like Twitter and Facebook, it's like really useless. Like you wouldn't want to share what lighting you're in.
Yeah, so can anybody imagine the Instagram integration? So they mentioned the Instagram there, and I can't even begin to guess. Yeah.
So I took it as like you get notifications through your lights. So like if you got a Facebook notification.
Yeah, so that's my only guess is that like the room gets more blue when somebody something. I don't know. I guess if you have enough LifeX bulbs, you can like render images. Other thoughts on that? Yeah.
You integrate like songs or something?
Yeah, so they started talking about like you can do these interesting things with the APIs. I'm not sure how much of that's actually been done, but definitely people have thought about like, you know, we're gonna light switch rave your house for you. Yeah.
I'm just curious as to how it's more efficient than like a standard light bulb, especially if you're like constantly changing colors and brightness.
Well, so part of it is that nobody is actually doing that. Like the reality is that most people set these things and forget them or change them occasionally. The efficiency claims come from the fact that they're LEDs. So it's just the efficiency gains of LED over CFL that they're talking about. And I'm sure in their like, this is 1,000,000 times better claims they're comparing to incandescents. Yes?
I can imagine this like being a little easier for people who are hearing impaired. I don't know how to do their account, but I know they have a in their house. I'm pretty sure that this would make the setup a little easier.
Yeah, so you could imagine like whole home notifications for the hearing impaired. I could dig it. All right, moving on. Fitbit is next. This is the one that I think is most likely to be owned by people in this class. Who has a Fitbit? Man, you guys suck. All right, so we've got like 4 Fitbits in the room. So Fitbit is absolutely crushing it in the like activity tracking wearables space. It turns out that's not a very big space. As best I can tell, they're somewhere in the $500 million to like $750 million revenue range, which means that they're nothing in the like consumer electronics space, but they are killing all the competitors in wearables land for better or for worse. Nike's gone now. The few other players that mattered are pretty much fading away. So for now, Fitbit is it. So since none of you has a Fitbit, I'll tell you all about the Fitbit. Anything could happen.
Hello once again, YouTube. This is Tech Geek 311 here on a soggy, rainy day. Going to give you a little app review of Fitbit.
Telling you, don't laugh. You're going to have to do one of these.
Okay, today I want to get into the app review of Fitbit. This is a fitness app. Tracks your steps, your weight, your food, everything that you would like. On this app, as you'll see, I'm using the Fitbit Flex. It's going to go ahead and sync and connect with my Flex. You can see on the very top, you got my photo. You have on there my steps. And then you can slide across and you can set your goal, whatever it is. You can also tweet your progress if you like. Below that, you're going to see the distance. And my goal is set at 5 miles. You're going to see the calorie burn. This is based on the input you put in for your weight and height. You can see my weight there. You can also look over here and it tells you where your BMI lies. It also tracks your sleep. So you can see I only got about 5 hours sleep last night. I can also look at your eating patterns. You can look in here and see your goal zone, see how many calories you burned. You can put in there your weight goal, what plan you want, your estimated date when you would reach it, and you can also have your water you've consumed. The bottom tab shows your activity. This gives you your steps activity level, your calorie activity level. You can even log in activities, so if you hit that plus button, you can put in there your exercise routines, my activities if you have any. You also have your weight on the bottom. You can set your measurements if you like, or you can just enter your weight in physically. Gives you lean versus fat. It gives you BMI. You also have your friends in there, so you can challenge your friends, see how much you've done. It calculates each time the day changes, you get the new calculation added. Going to more, you have the food. It's where you can log in all your meals. You can put in your common meals, meals you've created, any custom meals.
All right, so that's Fitbit. The thing I want you to notice on that one is that the app experience, the like overall service, actually has very little to do with the product, the connected device. So the Fitbit is this little thing that just tracks steps. That's all it does. It's a pedometer, and it Bluetooth syncs to your phone and can connect to the cloud through your phone and then tell the cloud how many steps you took. But then the app experience, the actual like process of using the device as a whole is all about like entering other activities and entering what you ate and putting in your weight and weighing in every day. And like there's all this stuff that just isn't really directly connected to the physical product. And that's true of a lot of these connected devices where Mike Kumnowski has a term for this where the device is an avatar for the system, and it's what you buy to kind of buy into the system. But it's not really just the point. Like it's trying to sucker you in and then get you to stay for all the other stuff. All right, we're gonna whip through a couple more of these because I got other things to do today, but the Innova Precision Cooker, this is the one that I most want. If anybody wants to bribe me, I want an Innova Precision Cooker. Who knows sous vide? Cool. Yeah, so these are sous vide machines where you attach it to a pot of water and it heats the water up to the right temperature for you. We'll watch a little of this.
Want to cook a gourmet meal while spending as little time as possible in the kitchen? You might want to try a precision cooker. I'm checking out the Innova Precision Cooker, which is a new sous vide set to come out later this year in October. It's designed for your kitchen at home and for at-home chefs, and the best part about it is you can even control it with an app. The Innova Precision Cooker cooks food in a water bath at a very precise temperature where the water is always circulating. It's really easy to set up, whether you're using the app or just setting it up manually. Just attach the Innova to any pot that you have at home, fill it up with water, and set the proper temperature. When it hits that temperature, then you're ready to cook. I just prepped a piece of Chilean sea bass, and it only took a couple of minutes. One of the coolest things about the Innova is that it's Bluetooth enabled, which means you can monitor the cook with an app on your smartphone. If you've already started a cook, you can use the app to monitor that cook's progress just to make sure that the temperature is staying consistent. Or if you're using a gradient-based recipe, you can make sure that the temperature is changing at the times that it needs to. You can also start a new cook. Just scroll through the app's recipes, find something that you want to cook, and hit the start button. The Innova will automatically begin to heat the water up to the temperature designated in that recipe. Innova is opening up this technology through an SDK that it's releasing to app developers, so they can create new apps for the Innova for iOS, Android, and Windows Phone devices. The Innova Precision Cooker will retail for $179 and will ship this October. Oh, and it looks like our fish is ready.
So that was ostensibly a review. So that's the Innova Precision Cooker. One more that you should be aware of is the DropCam Pro. So this is another company that got picked up by Google recently for about $500 million. And they are, quote unquote, reinventing the home security space in a way that makes absolutely no sense to me. So I'll let you just watch the video briefly.
DropCam's newest camera, the DropCam Pro, looks very similar to last year's camera. This is the DropCam HD, but it has a sensor that's twice as large and a new 6-element lens, which means that it can capture more detailed photos and video.
Yeah, you're too quiet. Forget you. The point of the DropCam is that it takes video and you can watch the video on your phone, and you can set it to like motion capture, like trigger on motion, and then it sends you a notification in the video. So basically the idea is that you're supposed to be like your own home security system where like you get the notification and you're like, oh no, the guy's breaking into my house. And then you do something about it. But I think that there's some obvious drawbacks to that, and I'll let you contemplate them on your own. All right, Sonos is the big player in connected audio right now, Wi-Fi and Bluetooth-based speakers. Presumed about $1.5 billion in sales. It may be a lot more. They're really killing it in this space. Again, I'll give you a little bit of this video.
Yes, again. Just watched our last video. We showed you some of the major Sonos components. In this video, we'd like to demo the Sonos app to show you how this system operates and how easy it is to use. Currently, I'm running this app on an iPad, but it will also work on an iPhone or an Android device. So over here in the left columns, list your rooms. Essentially, any room that has a Sonos component in here, we're going to name it, and it's going to show up in this list. So for our test here, I have the living room and the master bedroom. In the middle column here is telling us what's currently playing. Right now, we're on Pandora. It's not running, but the music that we're currently listening to is going to be in this column. And all of our available music sources are going to show over here in the right column.
All right, that's enough of that. The idea is that you go into the app, you pick things, they go to specific speakers, and then you can tell the whole house to like sync up to one audio source if that's what you want. So before we move into like the meat of this lecture, what are some kind of commonalities between those products that I showed? Yeah.
They all have a web app or mobile app.
Yeah. So they all have an app to control the device. Other things? Yeah.
All connected through some wireless things such as Wi-Fi.
Okay. So they all meet my definition of like connected consumer devices. Yep.
They all have like some sort of hardware device that's used particularly in the home, so consumers use it in their house.
Yeah, so these ones were all kind of home-based, just because that's what I actually do for a living. The other thing that's kind of interesting about these is that by and large, these all replace kind of one-to-one existing products. So the Nest replaces your thermostat, the Sonos replaces your stereo or your iPod dock, the Dropcam replaces what ADT would offer to you. They're all kind of innovative, but not that innovative. Like they're just kind of incremental progress over things that already existed in the home. And I think that's very common in this kind of first wave of connected consumer devices. And the next wave will be more about coming up with new things, like what can we do with smart technology, with connected devices that we wouldn't have been able to do with analog equipment. So that's where we're heading. The reading this week, you have one today and one for Thursday, was from Designing Connected Products. It's interesting, I think, to read a book that's like half done. It's kind of, it's a curious exercise. But anyway, the rest of this lecture is very much inspired by this book. I highly recommend it if you're interested in the space to just go out and buy it. And thank you to Claire for letting us share this with everybody. So I want to talk through some of the kind of design and engineering challenges of building connected devices real quick. Hopefully you got a lot of this from the reading, but we'll cover it just briefly here. The fundamental problem in building connected devices is that the device itself has limited capabilities. In terms of output, maybe you just have some LEDs or a tiny little display like this, or a single point of color. Like, you often don't have the screen and retina display that you're used to designing for. Input could be extremely limited. The Fitbit has one button and an accelerometer. The Hue light bulbs, I think, have nothing. There's no input there. The Sonos speakers, on contrast, have quite a few buttons. They have volume and forward and back and things like that. Computation-wise, you're more limited than you might be used to. So things like this have little microcontrollers in them, really tiny little processors. The Hue has, I think, an ARM processor in it. So you go up, the range is basically like cheap mobile phone processor all the way down to something that would have belonged in a calculator in the 90s. That's kind of your range of processing capabilities. And then in terms of network, sometimes you are lucky and you have full-on Wi-Fi. Sometimes you're very unlucky and you just have intermittent BLE sort of connectivity. And so the solution to this problem of you have a device and the device can only do very limited things is to distribute functionality across multiple devices. So the key thing is to move computation to the cloud or to mobile, and to move kind of touchy input sort of things to phones. And most of your reading, I think today's reading, was about this notion of coherency across devices. So how do you make one user experience that flows from a connected device to a phone to a web app to whatever else, while still kind of making sense as a single whole, not as just a bag of disjoint parts? And there are kind of three rules for this. Are composition, which is making sure that the functionality is distributed in a way that makes the most of each device. So if you have a touch screen on your phone and the person has that touch screen, you should move most of your kind of touch-based interactions to it as opposed to being on the device itself. The interface should be appropriately consistent across platform. So this is both words, data, and actions should mean the same things on both sides of the divide, and also about kind of making the visual design coherent across all parts of the platform, so that it's just not jarring when you go from the Nest to the Nest phone app. And then making sure that things are well synchronized between devices to aid in those sorts of transitions. is very difficult if you have devices that are kind of in asynchronous communication, and we'll talk about that in a second. The key thing to understand in the connected devices space, if you're a computer scientist and you're used to doing computer sciencey things, is that expectations are way higher in this space than they are in software space, and it's because people expect the real world to work. So if you're like on your computer and like you're typing up a document and Word crashes, you're like, oh no, Word crashed. Nobody saw that coming. And then you like get back to what you were doing. But if you like walk into your house and you turn on the light switch and like the house catches on fire, you're more upset, right? It's a bigger deal. Even if you just walk into your house and you flip on the light switch and the lights don't turn on, that is more kind of psychologically jarring to a person than Word crashing. I think that maybe we'll see this changing as younger people get older and the expectations for software get higher, and maybe conversely the expectations for the real world get lower. But we're not there yet, for sure. So people expect these things to work. They also are often used in critical situations where there's no backup device and no human intervention. So imagine you have a connected device that feeds your fish, and you leave on your vacation for 2 weeks, and like your fish feeder blue screens after like 2 days. Like you don't just have like a wedged operating system, you have like a tank full of dead fish. And that's really, it's dramatic. Like there's all these like dramatically bad things that can happen. You know, if your nest crashes in the middle of winter while you're on vacation in Florida, your pipes freeze and your basement floods. Like as soon as you start interacting with the real world, things get suddenly way more important. And it's one of the hazards of this space. You have to take that aspect of it pretty seriously. Context of use, in that sense, becomes a major part of the equation. So HCI people in the 80s had it really simple, where they were always assuming that like person is sitting at computer and person knows how to use computer and person has, you know, all the time in the world to deal with computer because computing is their job. Not so much the case anymore, as we've talked about in kind of the task analysis and contextual inquiry lesson, which was focused on more mobile and kiosk-based contexts. Here you have this even further, because at least if you're making the BART ticket machine, you like know where the BART ticket machine is. But if you're making a Fitbit, who knows where that thing's going to be used? You know, it could be loud, it could be dangerous, it could be wet, it could be bright. Anything could be going on around your user, and your user's attention could be split in any number of ways. And so the kind of key takeaway from that as a design principle is that your thing really needs to be tailored to the task at hand. When Nest first came out and when people first started making like smart appliances and things, the first thing everybody did was make the refrigerator be able to play solitaire, you know, make the thermostat be able to play Pong, things like that. But ain't nobody got time for that. Like you don't stand at your thermostat and play Pong. It just doesn't work that way. And so the more you can do to like tailor your software and your user experience to the actual task at hand, the more successful you're going to be in this space, because it's an elevated importance compared to the mobile computing space, and especially the desktop computing space. And then the active task is rarely intended to be your locus of attention for particularly long. So say that you are enjoying your Sonos speakers. You may spend a minute like getting your Pandora set up and getting it to go to all the right speakers. But then unless that's like the activity you're doing is like screwing around with your Pandora station, you're not likely to be attending to that for the rest of the time. You want that to kind of fade into the background and do its thing. If every 2 minutes in your house you're thinking about your thermostat is bad at being a thermostat, is the point here. Make sense? Okay. A major engineering challenge in IoT in general and in connected consumer devices is power. So some devices are expected to go days, weeks, up to months on like coin cell style batteries. Usually they're somewhere in the middle of that range for connected consumer devices. If you're lucky, you have power. You're a light bulb, although it turns out that's a real pain in the ass to be a light bulb. If you're lucky, you are just plugged into the wall, like a Sonos speaker. That's wonderful. But in the middle, there's things like the Fitbit that are expected to go, a weekish without having to be charged. Much longer than, say, a cell phone, even longer than a smartwatch. And so the main power consumption issue on connected devices is usually the radios. So your Fitbit, when it wants to talk to your phone, has to spark up a BLE connection, or just a Bluetooth connection, I think, and talk to your phone and send over all your data for the past however long. And that operation is incredibly expensive from a power perspective. They kind of cheat. Does anybody know how they cheat? How do they know when to turn on their radio? What's that?
I'm guessing when you plug it in.
So they do that. So if you're charging it, they just leave the radio on so that you can automatically sync. They have one other trick though. Yep. So that's how you do it on the phone side, but the Fitbit itself doesn't have any way of knowing that you did that, right? Yep.
Depending on whether you get sensor data, you get, say, the Fitbit accelerometer changes by a bit, and then you switch on your radio button.
Yeah, so there's some things you can do in terms of just actually monitoring the sensor. Yep.
Maybe like time of the day, people use it during the time, so is it time of the day we turn on?
All reasonable guesses, not right yet. Yep. No.
So when you tap the device?
So they do some of that. Yep.
It listens for RF noise on the frequency.
I think they do a little bit of that. They do some like very low level monitoring. But the main thing they do is if you have a Fitbit, you'll notice this. A lot of times when you fire up the app or you're on your PC and you tell it to sync, it won't work the first time. And you're like, what's going on here? Let me turn on my Fitbit and make sure it's still like got juice and everything. And you hit the little button that turns on the display. They spark the radio every time you do that. So they know that like you're attending to the device because it wasn't working the way it was expected to. And so they fire up the Bluetooth radio when you do that. So this thing can introduce like weird latencies, and we'll talk about why that's weird, but you have to be very careful to like work and sync on demand as opposed to just computing whenever you feel like it. And this notion of asynchronous communication is really key to both like the web and interacting with web services, as you may have noticed if you've done this week's homework assignment, and also this like cross-device IoT consumer electronics. So this is an example out of Designing Connected Products where they're talking about a thermostat, like a Nest, and say on your phone you say, all right, I want it to be 21 degrees, but you're here at SOTA, and your thermostat is at home, so you have to go up to the cloud, and the cloud has to somehow talk to your gateway, which is sitting at home, and then it has to talk to the heating controller, and then the heating controller has to talk to this thing, and it has to turn on that thing. And this whole process might be 10 minutes or something. It doesn't matter to you if you're here. You would have no way of knowing, right, whether that took 1 minute or 10 minutes. But if you're sitting there in the home, it maybe needs to behave differently. And so people have to do very clever things to change the communication model that's used based on where they know you are, how they think you're interacting with the device, things like that. There's a real challenge here. Does anybody know what it is? So you send up your thing to the cloud, and now it needs to get to here. Why is that hard? Come on, you're smart, computer scientists. Yeah.
So you need the gateway to communicate with the cloud frequently?
Yeah, so I mean, your basic problem is that there's a router right here, and there's a firewall there, and you can't just scream in that direction. It doesn't work that way, like NAT doesn't work that way. And so realistically, this thing is actually going out every couple of minutes and polling some internet service. It's very rarely an like actual push-based thing, although WebSockets are making that a little bit better. So latency is often everything. Users have this like deep psychological need for connected systems to feel like a unified whole. And latency on common tasks just doesn't work. So if you have your Hue light bulb there and you say like light bulb turn on, you want it to be like you turned on a light switch. It doesn't actually work that way today, typically. It's usually like a 1 or 2 second delay. And it's super, super disconcerting to people. Same thing with like skipping around in a song on Sonos. Like AirPlay is particularly bad about this. If you have like an AirPlay device and an iPod, if you seek in a song that's playing over AirPlay to a speaker, it'll take like 4 seconds. And people just hate that. Hate that. And so I think it's common today because we're still in kind of like early adopter mode for connected devices. But as these things go mass market, that's going to have to fall out of it. And so this is one of the things that actually we spend most of our time on at the Kenoma team, is that we have an engineering team of like 10 people. And of those 10 people, like 9 of them are working on latency in one way or another, like for connected device sort of applications. Cool. Latency is everything. We talked last week and a little bit before that about conceptual models. And the conceptual models world in connected devices starts to get really complicated really quickly. So imagine you have this Philips Hue system where you have like the gateway thing that connects to your router, and you have 3 light bulbs, and you have the mobile phone app. And let's imagine that you've scheduled this thing and told it, like, I want you to turn on every day at 10 p.m. and turn off at 6 a.m. Then imagine that your internet goes out at 9 o'clock at night and doesn't come back. Will your lights turn on? I don't know. Who knows? It depends entirely on whether that information about turning, the schedule is stored here or here or here or in the cloud. And the challenge there is that might be super important to you if you're a user of this system. Like maybe you've set this up to be your like security thing while you're away on vacation, or some other reason it's important to you. And if that's hidden away from you, you can't make good decisions about whether this is working. So for connected devices, you almost always right now have to instead educate your user about what the underlying system model looks like, rather than just hiding that away from them like we would prefer to do. Direct manipulation, which we talked about last week, is super, super difficult in connected devices. It's difficult because it's very difficult to specify complex behaviors. So imagine you have a home automation system and you want to set up that home automation system to sound the alarm and blink the lights when motion is detected on your drop cam. That thing that you're trying to specify is really difficult to do in a like drag and drop direct manipulation sort of way. Really, you're asking everybody in the world to become a programmer. Like you want them to be able to think about these things in a systematic way, do a like if this then that style process over the information that's coming in, and then do something reasonable with it. And then even worse, you have these massive articulatory gulfs of execution and evaluation, where input rarely resembles functionality. Like the spinning of the nest doesn't really directly correspond to heat coming out of a room. There's a major disconnect there in terms of articulation. And then feedback is very disjointed from the physical system. So if you set the Nest thermostat while you're here, it will be a while before you know what happened. And so feedback is a challenge. Skip that. Systems get complex quickly. And then the last thing I really want to talk about here is that industrial design is a big part of this. So unlike most of your software projects, here the industrial design of connected products really has to speak to how you use it, and really has to fit the customer's viewpoint of how the thing should behave. Like you could easily imagine a Philips Hue style thing that didn't look anything like a light bulb, but I can guarantee you they wouldn't have sold very many of them because people expect light bulbs to have this sort of light bulb deal going on. Okay. From an engineering perspective, there's a lot of challenges around competing standards and interoperability. We'll no doubt deal with that as we go further in the semester. But right now, there's these big silos of Lowe's has their Iris system. And if you buy a product that works with Iris, it will work with Lowe's Hub and their thing. Home Depot has Wink, and Wink works with Wink-related products, and like the two things don't talk to each other very well. Apple is notorious for making these sorts of like closed silos where like AirPlay is sort of like DLNA, except they screwed it up so that it doesn't work with your DLNA renderers and things. So there's all sorts of competing standards. And then security is like one last major issue. So everybody likes talking security about in IoT, and it really is a problem. Like, what does it mean if hackers or even just neighbors can get access to your fish tank controls and to your home lighting and to your security system and everything else? Who's played Watch Dogs? Really? What do you people do? What do you people do for fun? Kids these days? Dear. All right, Watch Dogs is fun. Go play Watch Dogs. It's a good treatise on this topic. All right, it's fun for like 6 hours, and then it's not fun anymore. All right, one little bit of this. I'm going to walk through what is a few highlight slides from what was a very long talk that I gave at O'Reilly Solid 2014. I'm going to post a link to that talk on Piazza just in case you're curious to see it, because it's kind of the like longest form recorded talk I have on like the process of designing connected products. But forgive the style change. So there's this kind of general process that we're talking about in this class of like you come up with a concept, you Wizard of Oz it, you do a low fidelity prototype, a high fidelity prototype, and then a production prototype. This relies on the platform being stable, and the challenge of designing connected products is that the platform is never stable. You are designing a software experience and a mobile companion experience and the like physical hardware platform all at the same time. And so unlike in mobile or desktop systems where you could count on somebody to have already iterated over the platform before you jump on to do your software work, now you have to kind of do both of those things at the same time. You have to be doing your hardware design and your software design and your mobile app design all in concert if you want to be doing meaningful user tests over those things. And so I will argue that as the like prototypey world was paper, low fidelity, high fidelity, the right way to go now is to do concept testing, paper prototyping, software simulation, hardware simulation, then real prototype hardware, and then custom production level hardware. And the goal is just to make user tests as useful as possible and to get out there as frequently as you can and do real user testing. So to talk very briefly about this, I would argue that the right place to start after you've done your paper prototypes and your like balsamic or your super low fidelity stuff is to get onto software, because there's very few things that like the Nest does or the Fitbit does or the Sonos does, the actual physical connected device, that can't be faked in software. And that's the right place to start doing a lot of this work, is to just build a piece of software, do it on the web or do it on mobile, do it Android, iOS, do it in Canoma, do it in a native programming language, whatever you want to do. But the right place to start is to build a mock-up of the interactive device that is at least somewhat functional. And then step 2 is to start thinking about how that actually interacts with physical hardware. So say you're building a smart alarm clock, and the smart alarm clock is going to have like a light sensor and a temperature sensor and an ambient noise sensor. And you want to build the device and build the mobile app to configure it. You should be in software building those two things at basically the same time, and then faking the inputs to the physical device. So faking there was a loud noise in the room, or faking it got bright right now. And I want you to think a little deeply about this, because this is where you're going in the project in this class. This is where we're stopping. This is going to be the end of our process, is that you will have designed a device concept, you will have designed a mobile app companion concept, and you will have prototyped the mobile app companion and done just a little tiny bit of this like device side simulation. But you will go no further. So you won't take the next step and like turn this into an actual device So none of the like Canoma Create, Raspberry Pi, BeagleBone, Arduino stuff. That's a different class. That's connected device design or interactive device design that Bjorn teaches. And then not the last step where you actually go out and do the industrial design and build the like final product. Make sense? All right, so we're going to talk about the project for the rest of the class and what you're getting yourselves into and how it's going to go. First things first, programming assignment 2 is due, is it due Friday or is that a lie?
Friday.
Friday, great. I know a lot of people are already done, which is good. I think this project was easier than the first one actually. So if you're struggling, like come and talk to somebody. And if you like kicked ass on this thing and you're already done, there's going to be this like horrible crunch on like Wednesday, Thursday, Friday as people start panicking and jump on the Canoma forums. If you understand this stuff at this point, get on the Canoma forums and answer people's questions and like collect all your participation points for the semester right now. Now is a golden opportunity for you to rack up those points. But I think this is pretty easy. So let me know if we're wrong about that. Groups will be coming out either tonight or tomorrow, probably tomorrow at our current pace. If you have like tremendous fear and you're thinking of dropping still, come and talk to me like in my office hours today and let me know what you're thinking. And be here on Thursday. Thursday we're doing the group brainstorm and it's required that you be here, and that whole assignment more or less, like the first 50% of it at least, will be done in class. So if you're not here, you just would basically get a 0 on that assignment, which is not the best way to start your group project. All right, so the topic for the final project is designing connected device experiences with a focus on the mobile app that goes with it. First step will be the brainstorm, and in the brainstorm, you will sit down with your group and you will brainstorm as many home or office problems as you can that could plausibly be addressed with a novel connected device and its associated mobile app. And then you have to also figure out like who has the problem. So you're brainstorming problems and users. And then you're going to pick one of those problems and user groups, and that's going to be what you're focusing on for the rest of the semester. So problem is kind of loosely defined. Problem could be, in the case of like the Disco Philips Hue, like my house isn't awesome enough. Like that's a valid problem. Yeah, we're trying to make this kind of as general as possible. But the important thing is that you can fabricate, you can make up whatever mobile device you want. Or sorry, whatever connected device, the physical product prototype. So you're never going to build this thing, and there's never going to be any feasibility analysis over it. So the like connected device side of this is like totally wide open to your imagination. Whatever you can come up with there. The actual like physical practical thing you're going to have to build is the mobile companion app. And for that reason, you're going to have to kind of pick a problem that will have some like non-trivial mobile relationship, just so that you have something to like go out and actually build. But the focus is on building mobile apps that would interact with some imagined awesome connected device. Could be a wearable, could be a physical consumer electronics thing, could be whatever you can come up with, as long as it's kind of in this connected device space. If it meets the definition on slide 1 of these slides, you're in good shape. Okay? And then one little bit to note here is that we really are cheating the device design process here a little bit, in the sense that if you were really doing this in real life, you wouldn't be saying, I know I need to write a mobile app and build a connected device. I better go find a problem that solves. Like typically you would hope that you're looking for problems in a more authentic way. And then if the solution to the problem is something else, like, you know, public safety, you know, public service announcements or education, then you would follow that path. But that's not a valid answer in CS160. You have to end up with something that looks like this, device plus app at the end of the day. Questions on that? Questions on the topic? I have like several more slides on the rest of the project, but do you conceptually get what I'm talking about here? In terms of you're going to have a mobile app that's going to be real. It's going to be like running on Android or iOS. By the way, we have iOS keys now. And we'll figure out how to distribute those to people, but if people want to do like real iOS development, we can do that. You know, all using Canoma, very fancy. But anyway, you really build the mobile app, and then you will have something running in the Canoma simulator that represents your device. So if we imagine the Philips Hue as our connected device, all the simulator, all the like device side of it would be one big freaking rectangle that changes colors. That would be your connected device. And then they would have some API that's like set color and brightness and schedule and whatever else. So you're kind of defining the API between the mobile app and the connected device, and you're doing something that is at least like marginally useful to represent the state of the device on the simulator. But you're not going anywhere near like actually building this thing. So if this thing is like a drone, you're not building a drone, you're building something that shows like the output of what that drone would be, that sort of thing. Make sense? We cool? Yep.
Do you get any credit for actually doing the device?
I would love for people to do it. I have Canoma Creates if people want to use them. I also can help you get things up and running on some other platforms if you're interested in it. We will decide whether there's any extra credit for that, but my inclination is to say no. But like if people want to do it for fun, they're welcome to. And really, it's this part of the project that could turn into like a research project, that Bjorn and I could keep alive as an undergraduate research thing. And so if you're interested in that side of it, I would encourage you to kind of do that on your own time or with your group on your group time. But then to focus for this class on this bit of it. Other questions? It happens that both parts are cool. If you watched like those videos at the start of the class though, 99% of interactions with these things really do happen on the like app side, typically. The physical thing does the like changes to the environment, but the like actual user experience is largely on the app. Okay? All right, so the next assignment after the group brainstorm, and this is gonna come fast, so I'm giving you fair warning, is that you will do contextual inquiry, task analysis, competitive analysis. And so the idea here is that you will go out into the world and learn about your target users and their problems, define some tasks that people are supposed to be able to do with your eventual solution, and then look into, do you have any competitors in this space? Are there other people doing similar things? And how can you be different? But this will be the first group assignment and the first of several where you have to like really go out into the world and talk to people again. So if you got all bashful on individual design 1 and 2 and like wimped out and talked to people you already knew, I will break you of this, damn it. We will eventually get you out talking to scary people out in the real world, and it will be lovely. The next assignment will be a low fidelity prototype. It will start probably as a paper prototype because those are really easy to bust out. And then I think we'll have you transition onto some prototyping toolkit so that you can do mock-ups. Maybe something as simple as Balsamiq if you've used Balsamiq. Maybe something a tiny bit more complicated. There are a lot of these like sketch out a user interface prototyping toolkits out there. But the deliverable on that assignment will be a video prototype, which is this very particular way of presenting a low fidelity prototype as a video and showing somebody working their way through it. Next will be low fidelity testing. So you will go out with your low fidelity prototype into the world and have people give it a shot. So you'll have to do the design of a user study, which actually that like methodological bit is the most important part of this assignment. So you design the study, you go out and run the study, you videotape it and audio record it, and you come back and you record any findings that you can, and then you'll analyze your results to inform the next iteration of your design. The next iteration will be the interactive prototype, which will be actually implementing your mobile app in Canoma.js and then getting it up and running on an iPhone or an Android device. You'll have to implement enough of the device side to like convey the message to your users so that your users aren't like confused when they're going out and doing this, like what's supposed to be happening. But again, it's like a simulator only thing. No necessary hardware, no double E. It's all just fake the user experience in whatever way you can. And even if that means like this thing is totally Wizard of Oz in terms of like somebody is manning the controls and making it magically do the thing it has to do, like that will be okay. It's really about the mobile app development and the like API bits for communicating between the devices. That's kind of the engineering bit of the course this semester, is on the cross-device communication. And then you will have a whole week where your groups will come up here one at a time and present the interactive prototypes. So that will be very exciting. I think that's a couple weeks after spring break or something like that. So look that up on the calendar if you're not sure. Yeah. That's something different. That's the final presentations. This is like the 3/4 of the way down sort of presentations. Then we will do pilot usability studies. So you will take your like actual mobile device out into the world and do another round of studies with another group of people, hopefully another group of random strangers that you have found. Every time I put up one of these slides that says you have to talk to somebody strange, there's about 20 people in the class, and it's consistent. It look terrified. I want to have like therapy with you guys so that we can get past this. Yeah.
It's just tough finding non-college students in a college city slash campus.
There's like 2 million people out there. I don't want to hear it. San Francisco is a mere BART ride away. Yeah.
Group sizes? What's the maximum cap?
4 to 5. Yeah. And we will be doing our like assignments on that tonight. All right, so this is all about like getting real people to really use it, capturing data. This particular study is going to be the more data-centric one. So in the low fidelity prototype test, you will be more just kind of observing and seeing like how people do. On this one, it's more about like measuring and like, how efficiently can people navigate your interface and where do they get stuck and how frustrated do they get. So again, this one will be a lot about like experimental design and experimental methodology. And then the actual execution should be relatively straightforward. Then the final presentations and poster session, I think right now we have this set for May 7th, which I don't think is dead week. I think it's the last day, what should be the last day of actual class. It's the last day of instruction. And you will give very super short presentations about the final version of your prototype. So you'll constantly be improving your interactive prototype from the first day that you start coding all the way up until here. And then you'll host a poster session where you show a live demo. And a lot of your final grade in this class comes down to this demo. That's kind of the reality of it, is that we'll have judges and outside experts and people that will walk through the poster session and talk to each of you, and we'll expect your thing to like actually work to at least some extent, to the extent that it can convey the intended user experience. So that's that. And then finally, you'll make one last 5-minute video that you'll submit to us, and you'll turn in your code. And my preference is that everybody put their code up on GitHub or something and open source it. I think that's the right thing for you guys to be doing in terms of portfolio building. So some combination of like Hackster.io or Behance and GitHub will be kind of your final like submission. All right, and then the like final criteria we will use to judge you will be how ambitious was your project, how complete is your implementation, how usable is it like actually useful, and then does it like make sense from a visual perspective? Questions on that? Thoughts, concerns? We've already covered fear. Yep. Is it? All right, I'll look into the dates on that. We may be off by a week. I'll figure it out. Although maybe it's better if it's dead week. You guys tell me. Like, if I have to take like 3 hours of your day, is it better to do that 3 hours the last week of instruction or the following week? All right, well, I'll put a poll up on Piazza. This is, sorry, I don't know as an outside person like what is common here, so we'll sync up with people. Other questions? Thoughts? All right, be here Thursday, group brainstorm. It'll be very exciting.
And I think the concern with doing it during instruction week is that some people may have classes.
Sure.
Unless we split it up during the last 2 weeks of classes.